warahmatullahi wabarakatuh. In this video, we will solve example number 11, 12 and 13 of problem set 3 from the chapter Arithmetic Progression. 11th example. If the first term of an AP is A, the second term is B and the last term is C, then we have to show that the sum of all terms is A plus C into B plus C minus 2A upon 2 into B minus A. So here the given thing is the first term, that is T1 is equal to A, second term T2 is equal to of an AP is B, and the last term Tn, last term is denoted by Tn, so Tn is equal to, it is C. Now therefore as it is an AP, so D difference, common difference between two terms, that is T2 minus T1, which is equal to T2 is B minus A. So D is equal to B minus A. Now we know that for an AP, for an arithmetic progression, Tn is given by the formula Tn is equal to A plus n minus 1 into D. Now we substitute the value of D, A and Tn in this formula. So Tn is C, C is equal to A, the first term A plus n minus 1 into D is equal to B minus A. Here we find n. So now we'll take this C on left hand side, therefore we'll take this A on left hand side. So C minus A is equal to n minus 1 into B minus A. Therefore now we'll take B minus A on left hand side. So here it is multiplication. So on left hand side it will get divided. Therefore C minus A upon B minus A. C minus A upon B minus A is equal to n minus 1. So it is equal to n minus 1. Therefore n will be equal to, changing the signs of equality. So I am taking this left hand side, and on right hand side that is n minus 1 is equal to C minus A upon B minus A. Therefore n is equal to C minus A upon B minus A. Minus 1 will go on right hand side, it will become plus 1. Therefore cross multiplication. So C minus A plus 1 into B minus A. 1 into B minus A is B minus A upon B minus A. Therefore the value of n will be C plus B minus A will become minus 2A upon B minus A. So value of n is C plus B minus 2A upon B minus A. Now we find the value of sum of the all terms. Now the first term T1 is A, last term Tn is equal to C, and n is equal to B plus C minus 2A upon B minus A. Now using the formula Sn is equal to n upon 2 in bracket. When first term and last term is given, we use this formula Sn is equal to n upon 2 bracket T1 plus Tn. Now we substitute the value of n, T1 and Tn in this formula. So sum of all term Sn is equal to n is equal to B plus C minus 2A upon B minus A whole divided by 2 into T1, that is A. T1 is equal to A plus last term Tn is given as C. Therefore Sn is equal to sum of all terms, get here B plus C minus 2A whole divided by 2 times B minus A in the numerator into C plus A. So this is the sum of all terms of an AP when first term, last term is given. 12th and very important example. If sum of first P terms of an AP is equal to sum of Q terms of an AP, then you have to show that sum of P plus Q terms is equal to 0. Here P is not equal to Q. Now you know that for an AP, for an arithmetic progression, the sum of n terms is given by Sn is equal to n upon 2 bracket 2a plus n minus 1 into d. We use this. Now we know that for an AP, sum of n term is equal to n upon 2 bracket 2a plus n minus 1 into d, where a is the first term and d is the common difference. Now it is given that sum of p terms is equal to sum of q terms. Now for n is equal to p and n is equal to q, we will use Sn for sum of the n terms, Sn formula. So substitute here for n is equal to p upon 2 in bracket 2a plus p minus 1 into d is equal to q upon 2 in bracket 2a plus q minus 1 into d. Now on both sides of the equality there is 1 upon 2, 1 upon 2. We can cancel 1 upon 2 from both sides of the equality. Now multiply, we open this bracket on both the side of equal to sign. So p into 2a, that is 2pa plus p into p square, and we multiply by d to this bracket only for this bracket. So into p square d minus p into 1p into d is equal to, here q into 2a, that is 2qa plus q into q square, and into d minus q into 1, that is q into d. Now taking all terms on left hand side of the equal to sign, like terms taking together, so we'll get next term. Next step is therefore 2pa minus this 2qa will come with 2pa, so 2pa minus 2qa, so 2pa minus 2qa plus the next like terms here p square d and q square d will take together. So p square d is plus q square d will come on left hand side, it will become minus q square d. So p square d minus q square d on left hand side. Next minus, here minus pd and this minus qd will come on left hand side, this term will take together. So minus pd plus qd, minus pd plus qd is equal to 0. Now grouping the two terms and taking the common terms from each two terms here. So now if you see here, the common terms are here, 2 is the common and a is common in these two terms. So we will take therefore 2a in the bracket p minus q plus here d is common in bracket p minus q square. Here minus d is common in bracket p minus q is equal to 0. Now here we can apply the identity for this term, that is p square minus q square. That is, we know that the identity a square minus b square is equal to a plus b and a minus b. So therefore 2a into p minus q plus d into p plus q into p minus q minus d into p minus q is equal to 0. Now we divide this equation by p minus q throughout. So dividing p by p minus q each term of this equality, since p minus q is not equal to 0, it is given p is not equal to 0, so p minus q is also not equal to 0. it is given that P is not equal to Q. So P minus Q is also not equal to 0. So denominator is non-zero. So we can divide here. P minus Q will get cancelled. So we get here 2A plus D into P plus Q minus D is equal to 0. Therefore 2A plus, taking this D common, we will get here P plus Q minus 1 into D equal to 0. We will name this equation as the equation number 1. Now for an AP, for an AP, sum of P plus Q terms, sum of, that is SP plus Q, SP plus Q is equal to P plus Q upon 2 in the bracket 2A, at the place of N will put P plus Q. So plus P plus Q minus 1 into D. Now see this term, that is 2A plus P plus Q minus 1 is equal to, here is equal to 0 from 1. So we can write here P plus Q upon 2 is into 0, which is equal to 0. So sum of P plus Q term is equal to 0. 13th example. If m times nth term of an arithmetic progression is equal to n times nth term of an AP, then you have to show that n plus nth term of an AP is equal to 0. So here we know, let us assume the A be the first term, let A be first term of an AP and D be the common difference. D is the common difference. So for an AP, for an arithmetic progression, Tn, you know, Tn is equal to A plus n minus 1 into D. Now use this formula for n is equal to n and n is equal to n. So it is given that, here it is given that nth term, n times nth term, n times nth term of an AP is equal to n times nth term of an AP. So substitute the formula here for Tm and Tn, for A, for first term A and common difference D. Therefore we get here m into A plus n minus 1 into D is equal to n into A plus n minus 1 into D. Multiplying this on left hand side by the m, this bracket by m, open the brackets, m into A, that is ma, plus m into n square, and multiplying this bracket only by D, so into D, minus m into 1, that is n into 1 into D is D on left hand side, which is equal to, see, in the same manner multiplying by n to this bracket. So here n into A, na, plus n into n square, and multiplying this bracket by D, so into D, minus n into 1 n into D into 1 is D, n. Now taking all terms on left hand side and taking together the like terms, so here ma and na will take together, then m square d and n square d will take together, and minus md and minus nd will take together on left hand side. So ma, therefore na minus na plus m square d, this plus n square d will come on left hand side, it will become minus n square d. So n square d minus n square d on left hand side of equal to sign. So next is minus md minus nd. Here plus m square d minus n square d minus md, and nd will come, it will become plus nd. Now grouping the two terms and taking common from each two terms. Here the common term here is a, so in bracket m minus n, plus here the common term is d, in bracket n square minus n square, minus here d is common, so in bracket m minus n is equal to 0. Now here m minus n and here n square minus n square. So we will apply the identity for this term, m square minus n square. Therefore a into m minus n plus d into m plus n into m minus n. Applying the identity, a square minus b square, that is a plus b and a minus b. So here m square minus n square is equal to m minus n and n plus n, minus d into n minus n is equal to 0. Now dividing this equation, it is by n minus n. So dividing by n minus n, each term of this equation, n minus n upon n minus n, dividing each term throughout, since m is not equal to n and m minus n is also not equal to non-zero. So m minus n is also non-zero. So we can now divide. M minus n will get cancelled from each term. So we get here a plus d into m plus n minus d is equal to 0. Therefore a plus, taking d common, so m plus n minus 1 into d is equal to 0. So using formula of Tn, that is for m plus n is equal to m plus n. So here we will get as this term is t m plus n, a plus t m plus n in minus 1 into d, which is equal to 0. Hence we have proved it that sum of t m plus n is equal to 0. Last example, rupees 1000 is invested at simple interest, 10% simple interest. Check at the end of the every year if total amount is in arithmetic progression. If this is in AP arithmetic progression, then find interest amount after 20 years. For this, complete the following activity. Here the simple interest formula is given, P into R into N upon 100. Therefore, simple interest for after first year at the rate of 10%. After first year, number of year first year, that is 1000 into 100 into 10 into 1 upon 100. So 0 will get reduced from to numerator and denominator. 10 into 1 is equal to, that is rupees 100 will be simple interest after 1 year. Now simple interest after 2 years will be 1000 into 10 into number of years is 2 upon 100, that is 2 zeros from numerator and 2 zeros from denominator, we can cancel. 10 into 10 into 2 is equal to 200 rupees. Then simple interest after 3 years will be, here 1000 is the principal amount, then rate of interest 10, and after 3 years 3 is equal to, here 2 zeros from numerator, 2 zeros from denominator will get reduced. 10 into 10 into 3 is equal to 300. Now according to the simple interest for 4, 5, 6 years, years will be the, that is for 4 years 400, for 5 years 500, and for 6 years it will be 600 respectively. 100 rupees will get increased every year. Now the arithmetic progression will be 100, 200, 300, 400 and so on. So the common difference is T2 minus T1, that is 200 minus 100 is equal to, that is D is 100, and the first term is also 100 of the AP. That is, now an amount of simple interest after 20 years is given by Tn is equal to A plus n minus 1 into D. So A is equal to 100 and D is also 100, that is 20 minus 1 into D. So 100 plus 20 minus 1 is 19 into 100, which is equal to 100 plus 1900, that is equal to rupees 2000. So the 20 amount after 20 year, it will be, into simple interest will be rupees 2000 rupees.